And we are live. Hello, everybody, and welcome back. I'm very excited today to be joined by Diego Favarolo. He is the founder of SpaceAI. This is a really exciting project, a project that I've been following and supporting for a little while, and I'm really excited for you guys to hear more about what they're doing. Diego, how are you doing today, my friend?
Very good, Tony. Thank you very much for organizing this interview.
Very happy to have you here, coming to us live from Patagonia. Is that right?
Right, exactly.
Very good. Some of the best things get done in the wilderness or at the end of the world, wherever it may be. But we're here to talk about space AI. Diego, I'm really interested in space AI because you guys bring together a number of different capabilities: the space economy, Internet of Things, blockchain, abundance-based economics, a whole raft of different independent and now conjoined disciplines and domains, all under one roof, which many others have tried to do independently, but you're trying to do all together, which is what I think makes space AI truly differentiated and truly exciting. For those people who don't know you, please give us your brief introduction. Tell us your background. How did you get involved with space AI? And let's start there.
Well, thank you. Yes, well, I'm originally from Argentina. I started one of my first company at the age of 18, which is one of the largest internet companies still in Latin America. And well, then after the exit of that company in 2012, I crowdsourced the development of the first open source 3D printed rocket engine. There we were testing basically the capabilities of developing complex technology in a distributed manner. And well, that was a complete success. And well, we did it. NASA participated into that, and we literally destroyed the rocket science complexity, transforming a rocket engine in a free downloadable file. And well, in 2013, I was nominated with Elon by the World Technology Network around, well, basically that work that we done there. And that was the opening door to the space industry and starting to understand the opportunity and the meaning of what is happening right now. That is not only an industry, it's that we are evolving as a species. We are becoming multiplanetary right now. So that was the beginning of space AI.
Very interesting. So going from creating a successful internet business to open sourcing a rocket, and now going even further. So for those people who don't know, tell us a little bit as an introduction around space AI.
Well, space AI started in 2015. Between the US, Argentina, space AI, there we started to develop around the CubeSat standard. That is an open source standard for hardware that was being used only for satellites until us. And well, understanding a new cycle of the computing industry that is one of our pillars of building our architecture. That is, well, what everyone knows as the edge computing. That is basically that the data center has disappeared. And we build from there, from understanding that new computing cycle, from understanding that we are becoming multiplanetary, so we use a satellite open source standard for our hardware. And the other thing is, also a protocol that, as well, some people may know, is CCSDS. That is the new space internet. That is not internet from space. It's that new network. So understanding those three variables is how we started to work, and we have developed the hardware, the software, the network, and we are already deploying networks and launching satellites to space.
Fantastic. It's very interesting and even just to be having a conversation with somebody who has been that close to so many different domains that are already beyond the understanding of most people. But I think the intent with this show today is that we'll try and normalize it a little bit, try and help people understand the potential of the technology, the use cases that you're already working on in space and also on Earth still, because I think, as you mentioned before, this is technology that can still be used on this planet for the time being in a number of different ways. What I'd love to highlight also is this is a LinkedIn Live. So those people listening in, do give us your GMs. Let us know where you're coming from. Anybody else listening from Patagonia, please do let us know. Anybody listening in from anywhere else around the world, please do put your questions or comments for Diego in the comment section under this LinkedIn Live, and we'll try and get to as many of them as we can during the show. We'll try and demystify as much about the space economy as we can. And hopefully that'll leave you guys with a better understanding of the potential and hopefully a little bit of affinity towards space AI. Further to that introduction, Diego, I think from what I understand, a big part of your work on the space economy and with space AI was founded not necessarily from wanting to create a better product, but actually from wanting to create abundance and from a particular theory or a particular base of theory. Could you give us a little bit of an introduction? I won't try to ruin it, but there's some economic theory behind space AI before we get into the space rockets and IoT devices, right?
Exactly. Well, as you have mentioned, is also the essence of our work. And well, based on Professor Jeremy Rifkin, that is an economic professor of Wharton, he's in his book of the Zero Marginal Cost Society, he's describing a new economic model, a new economic system that he said that is already operating, that is deployed, and that is the first time in history where we can observe a new economic system that is in parallel to the traditional capitalist market and the opposites, communism and socialism. He called that system the collaborative commons. And when we think that we are becoming multiplanetary, and what is the economic system in space? Well, we strongly believe that collaborative economics, collaborative commons is the answer for what is the economic system in space. So around understanding that and the concept of the zero marginal cost, that is basically what is the extra cost for producing an extra unit of a service or a good. And understanding that we are moving from scarcity to abundance, and based on the zero marginal cost principle, is how we, based on the architecture of a satellite that is always a solar panel, it cannot depend on the electricity grid, is where we start from the energy at the zero marginal cost. So if we have the energy at the zero marginal cost and we start adding another layer of resources on top, like computing, storage, and communications, we can arrive to a computer, a distributed computer that is running at zero marginal cost, powered by solar energy. And that is the base of the model that we are deploying. And as you have mentioned, at the end, the essence of this is understanding this economic system where we are orchestrating abundance instead of scarcity.
I absolutely love that. And this hits a tone with me personally. I've been a big follower of Peter Diamandis, Singularity University, and a number of different thought leaders who look at the opportunity for creating open, collaborative, I don't say anti-competitive because that's not the true sense of the word, but the opportunity to do more with more and the opportunity to create more, and how economies or how businesses work when they have shared incentives or when they're not trying to zero sum each other down to the lowest possible marginal cost. What you're saying is zero marginal cost, not zero cost, but when you have abundant energy, when you have access to abundant resources, you can progress innovation faster, you can progress information faster, you can progress collaboration faster. because you're not getting in the way of, you're not thinking about competition. You're actually just thinking about the certain things that we don't need to compete over and we won't. And in your case, that's compute, storage, communication, energy, and I suspect a few other things as well.
Yes, exactly, because around that distributed infrastructure of computing, what is the third layer of resources that we can build on top of that is the distributed AI. And that is why the name of the company is SpaceAI.
Very good. We've got it. So some comments already coming in, guys from all over the world listening into this particular show, which is fascinating, from the US, from Argentina, from China, all over Europe as well. Real interest in the work that you guys are doing, which is fantastic. What I'd love to jump to next, Diego, obviously this show is called Blockchain Won't Save the World. So there's usually a little bit of a blockchain angle to it. So given the introduction to the Collective Commons and Professor Rifkin's work, what is the role of blockchain in the space economy, and how are you guys thinking about making use of distributed systems, distributed ledgers as part of the SpaceAI proposition?
Well, if we go again to a perspective of the space economy, and if we are a multiplanetary civilization, what do you think is the right answer for the economic transactions in space? I think that crypto is the only answer there. So that's why we have integrated in our architecture the ability for the nodes to transact different crypto assets. And you can be in the public collaborative network, or you can build basically set up your private cluster, and with your private blockchain layer that can be integrated also to the public network. But the basic why is because we start thinking from the space economy, and I think it's the only answer that we have.
I really like that. And to be clear, right, if you've got this sort of multi-planetary, multinational cluster or connection of devices, machines, places where people live, space stations, rockets, etc., do we want to set up a space government? Should there be a space EU, or should there be a single party that's responsible for policing, governing, banking these transactions in space? Or can we progress beyond that to say, rather than having a centralized entity, how can we use distributed systems and the philosophy of distributed systems to allow there to be systems that can't be hacked, can't be gained, can't be evil, because they are protocols, they are open source, and they are designed exactly so. And I think that's what you're saying broadly.
Definitely. Again, if we think from the collaborative commons economic model that, Professor Rifkin said, that is without intermediaries, peer-to-peer, and when we have to, respond your answer, if we need the government there, I think that the answer is no. But we can definitely, have our rules program in a blockchain where we have the rules of how that collaborative economy is operating, and that should be all. We don't need to export bad practices to space.
Very good. It does give us an opportunity to create new models. And again, I mean, if you look at even basic models of how we see the International Space Station, you see cooperation between different parties in space. When you're further away from the ground, when you're further away from the places where humans have traditionally been operating, the stakes are higher, the risks are higher, the cost of failure is higher. And so you start seeing collaboration in these, you could consider the International Space Station to be like a private network. Right? It's not an open access network. Anybody can come in, anybody can dock, anybody can stay. Right? It's not quite the Bitcoin of space yet. It's more like a Hyperledger Fabric network or an R3 Corda network of space for the time being, localized standards, etc. But it's got to be, the direction of travel has got to be open, collaborative, transparent, and not governed by single entities.
Exactly, and it's a very good example. There you see Russia with the US and Europe, Japan, in all together. That's why the space perspective is a good point of view.
Very good. And let's build on that with kind of your view on distributed systems and particularly kind of open standards, because I guess what we can observe in Web3 and certainly in Web2 is the creation of multiple proprietary standards, the creation of an almost infinite number of protocols, each one saying they're better than the other. And over time, you've seen some moves away from some sort of view of chain maximalism, saying my blockchain is the best, my technology is the best, everybody will adopt my standard. And I will bring all of their network effect over to my system, and then my system will become the new standard. And vice versa, right? Can be with blockchains, can be with whatever else. And then over time, you've started to see a little bit of a relaxation of that view as to say, well, we've got certain protocols that are very good for certain things, whether that be settlement, whether that be for data protection, security, speed of transactions, whatever else it might be. We can keep some of these different protocols. We just have to figure out a way for them to interoperate. And then you've got non-Web3 protocols, systems, the internet, the web has its own protocols and so on. And space does too. You mentioned CCSDS.
Exactly.
Talk to us a little bit about what it's like building a blockchain, IoT, and AI business in and around all of these open standards.
Well, yes, exactly. We believe that open source is the winner, and that we basically should integrate and build on top of what we already have. And at the layer 0 of this perspective, we have CCSDS protocol that, for the people that don't know, that is the first time in history that we can observe a real new network on top of the terrestrial internet. And that protocol is where, for example, the rovers in Mars, the satellite in Mars, the International Space Station, and a lot of spacecraft also in the moon, and all the deep space networks on planet Earth are already operating into that protocol. There are thousands of machines and nodes into that network. So we believe that that is basically the base architecture of the next network, and we have built on top of that. So at the base of our architecture, software, and network, we start with CCSDS protocol, and we are basically already using it, and we have integrate the collaborative commons or the collaborative economic model into that protocol. So you can be exchanging resources of computing, storage, and communications around that protocol right now.
Fantastic. And so as you said, you've got additional protocols above and beyond the traditional web protocols that are designed to work in space, designed to work between machines and devices. And the intent is that we're creating this sort of giant distributed edge computer in space, which covers compute, storage, communication, transactions as well. So value transactions, if you start including micropayments or the movement of cryptocurrencies or virtual currencies or digital assets, whichever terminology you prefer to use at the time. There's also a pretty fundamental part of this, which is the IoT device, right? Which is exactly. the actual device. And I believe in SpaceAI, it's called Neo. Do you have a Neo with you at this time, Diego?
Always.
Always has one with you. And
Always.
This is it, right? Talk us through. This is the core of the IoT part of SpaceAI and this distributed network. Talk us through what's in the stack.
Well, as I mentioned before, we use the CubeSat standard as the standard for our physical layer, because as I mentioned before, we believe that is the right answer for the standard to target infrastructure and unmanned systems. As we can observe already in Mars, where you don't have humans and you have rovers, satellites, and different Internet of robotic things or infrastructure operating. So with that perspective and with that target, we have developed a Pico satellite that is smaller than the nanosatellite, that follows the satellite architecture, and of course is solar powered and has batteries and the ability to orchestrate the energy that the machine is consuming, and has different modules, exactly as the CubeSat standard, where you connect different boards, where each board contribute different capabilities to the machine. And starting from the minimum unit that is one board that targets and solve a problem for infrastructure, Internet of Things, small robotics applications with integrated sensors for navigation and positioning, storage and wireless communications. That is the minimum capability. And from there, you add communications with software-defined radio communications, higher computing capabilities to more complex unmanned systems, for basically being able to process sensors that needs more computing capabilities, and for AI on the edge. With these different modules, depending the problem, from infrastructure to unmanned systems, you add more or less modules, and you can be, using for the first time, it is a small satellite on planet Earth to target Internet of Robotic Things and distributed infrastructure applications.
That's really interesting, and there's a really important point you made at the end there, which I think some people will miss. This is not just a sensor array, or this is not just an accelerometer in space, or we're not just sending our iPhone up and strapping it to a satellite and it does the same sorts of things. I think the performance that's required for that particular hardware is quite different, and there are some use cases or requirements where clearly it's designed to be suitable for the conditions of space, the distances, the communication standards, etc., in which they operate. But on Earth, there's also some performance benefits too, in terms of the connectivity to satellites, but then also the, the reach.
Exactly. Well, for communications, we have machine-to-machine communications. And when we are in the ground segment, that is the technical word from the space industry perspective of this planet.
Ground is just not space, right? Ground is back on Earth, as opposed to the ground is, you have space, ground. Got it.
Exactly. So we have agnostic wideband communications. That is the technical word. To do that, we use software-defined radio. In this first release, we are only operating in the radio frequency spectrum with agnostic wideband communications that allow us to basically operate with different pre-existing communications infrastructure in space and on Earth, like cellular network, different constellations for communications, or other services that you have already from space. And other way of using the node on the ground is it can be set as a 5G solar powered station that is only 5 by 5 centimeters, and that is how is the communications of the capabilities of the node right now.
Got it. And these things, obviously, you can put them on a satellite, as you said, a constellation. You can put them underwater. You can put them underground, right? These things are pretty hardcore.
Exactly, because we are using it for different type of unmanned systems and for infrastructure. Always the same building block, open source satellite on Earth.
Very good. And while we're on Earth, we've got a question here from Carlos. This is one that we were going to cover anyway, but let's talk through some of the use cases or the applications for NEO or for SpaceAI on Earth. Right, we'll get to space in a minute, but I think it's important for people to realize that SpaceAI tech can have a huge, profound impact on Earth as much as it can in space, or can bring together capabilities on Earth and space together. So talk us through some of the use cases or some of the types of organizations you're working with.
Perfect. Yes. Well, we are using it already for different type of distributed infrastructure. For example, in California, is a distributed prosumer network that basically is integrated with different energy assets and homes and even electric cars, where you have a distributed network that is independent from the electricity grid, is independent from the internet, and is independent from the cloud. Because with those nodes into that network, we have a distributed computing capability, distributed processing, distributed storage, and distributed communications. Then another case is in gas pipelines, where we are monitoring in real time different gas pipeline infrastructure in the middle of the desert with underground nodes. You don't even see a solar panel, you see nothing, and it's underground monitoring and with communications to space. Then a very good case for unmanned systems is a company that is a rocket manufacturer that is integrating the nodes to the vehicle. And well, as we are a satellite standard, we pass through all the checklist to be on that vehicle. And well, we've been already in several flights of that vehicle, and there will be at the end of September another one that will go to space. And then for agriculture applications, and also unmanned systems for ground, like UGVs. For example, was one of the first things that we did when we started SpaceAI. That was the first self-driving car of Latin America, to demonstrate the vision of applications of the hardware and the software and the network.
Fantastic. A lot to unpick there. Let's try and see if I can remember each one at a time, and maybe help me as we go along. But the first example you gave, the Californian example, where basically you're creating a separate network, a node connected network of electricity prosumers, devices, vehicles that can trade energy, trade, compute, share information with itself, and exist fully separate, fully isolated from any grid provider, energy billing company, etc. Fully separate, I don't want to say autonomous, but semi-autonomous remote energy system in California today.
Exactly.
Super interesting. And again, I mean, that's really just a ground example of the same case that you're presenting in space. Right? It's saying that you know, instead of a house, it's a satellite, and you know, instead of a Tesla, it's a space station. But broadly speaking, you've already replicated the space model, which I think is super interesting. Oil and gas. The underground part is interesting to me, is that you've got a device that's hardy enough. You know, the Neo box is basically buried underground, is constantly monitoring gas flow pipelines, which oftentimes come under attack, either maliciously or for profit or for whatever else it can be. And also the sensors that typically get attached to these sorts of pipelines are also very valuable. These things have rare earth metals, they have useful equipment, and people will often take those devices. So if you've got a device, a monitoring device that you can hide, that gives the pipeline operator a bit of an advantage. And also it connects to space. So you don't need to connect some sort of local area network or some Wi-Fi network in the ground. You've basically got your own Starlink buried underground monitoring your pipelines, which is super powerful.
And you have a mesh network within those nodes, where you have if you have 10,000 kilometers with nodes, and you have a node every 1 kilometer. You have your edge computing infrastructure with your storage, your communication, and the communications capability independent from any infrastructure.
Very, very cool. And so you've got that kind of network of nodes existing on ground, underground. Then the rocket example, as I recall. So that's basically the space economy vision that you have, is saying that this is going to be something that's part of devices that are going to go to space, whether it's reusable rockets or single use. You've got a CCSDS open standard ready communication, processing, sensing device that can go up with any rocket anytime, which again feels like this is part of fulfilling the prophecy of what SpaceAI is all about.
Exactly, and in the most extreme case of an unmanned system, it's a rocket.
And then a slightly less extreme example of an unmanned vehicle was your self-driving car in Latin America. I've driven some roads in Latin America, and I would say maybe in some particular roads in some particular cities, it might be more dangerous than sending a rocket to space.
Well, it's a completely opposite algorithm that you, for other parts of the world, if you have the stop sign, it continue, because if not, you will crash. But we applied in closed circuits where you can very easily, the variables are different than the one that you have outside a closed circuit, because exactly for what you said, and it was in a very early stage of the development of that sector that I think still in Latin America is not regulated. So
indeed, there's no stop signs in space yet.
Not yet. It's a warp speed maximum allowed.
Very good, very good. I've got a couple of questions here, so I might pick off a few of these at the moment. Particularly at the moment, how many space AI devices have been to space, are up in space? What's the plan around the constellations at this point in time?
Well, we launched the first satellite in 2021. And right now we are in a process of manufacturing and integrating the constellation with missions that go to the International Space Station, to low Earth orbit, and the moon. There is the roadmap and the architecture of the constellation is a distributed computing constellation where you have processing in CPU, GPU, storage, and wideband agnostic communication, so we can interact with other satellites, and we have space-to-space computing services, and even AI in space.
Amazing. And one of the few projects that I've ever come across using blockchain that has the actual moon on their roadmap.
Exactly, because there are, I think, from here to 2030, 254 missions to the moon already in progress.
Wow. Okay,
and
so it's busy.
Is the moon economy that is happening right now. So, and there we are an enabler, and we lower the barriers to the agency and all the, because what you have right now is private companies there. It's not only governments. So with our platform, we lower the time of development, the cost, and basically also we increase the capabilities and the benefit that you get from the same investment, because you only need to build on top to do what you need to do, and you don't need to start from scratch to have your space platform for robotics or infrastructure.
Love that. Let's go a level deeper, if I may. We've got a question here from Alex, who, again, I probably don't have the technical knowledge to frame this one exactly, but talking specifically around the capacity for a single node, power consumption, life cycle. Tell us a little bit about NEO and what is its operating parameters today?
Well, we have from the communications perspective, two types of software-defined radio options. One for low bandwidth that, as Alex is writing there, that it can operate with the LoRa protocol and devices. Then from Line Microsystems, we have a more complex software-defined radio that operates from 100 kilohertz up to 3.8 gigahertz in the radio frequency spectrum. One important thing around that is we have an integrated nano antenna that is wideband that allows us to exploit all the capabilities of the software-defined radio. That is basically all the radio frequency spectrum that you cover with that software-defined radio with the same antenna that is a small nanomaterial. Then we can interact and operate as a client with traditional cellular networks, from very old networks up to 5G networks with downlinks of 4 gigabit per second. And the node, it can be set in just one click as a 5G station. So it becomes the host of the other nodes in the cluster. So that is the architecture and the features around communications. And we also have Wi-Fi and Bluetooth. And if you need to connect an Ethernet, you can plug in a cable. And
if you want to go really old school, if all of that was too much for you, you can still just plug it in.
Yes, you have also that option.
Very good. So in reality, depending on what your configuration is, you can have incredibly fast, incredibly wide, operating at different frequency bands, and pretty much serves most of the understood space and ground use cases at the moment. I want to jump on to what's next. So obviously you've got existing network in space. There's more coming. There'll be moon activity or moon-based missions where NEO and SpaceAI will be present. Just talk us through the roadmap in general. So what can we expect next for SpaceAI, and how can people get involved?
Well, we are exactly in a moment where you can go to spaceai.com and you can register as a user within the network and basically declare what are the resources of computing, communications, and storage that you can contribute to the network, and you can sign up to the waiting list for a node, because we are in a moment where we are releasing not only the software and the network, it's also the physical NEOs to consumers and to users to increase the capabilities of the network with the features of NEO. So that is one of the things that is happening literally right now. And as I mentioned before, we are working very hard in the satellite manufacturing and integration in the UK, and we are in line to start deploying the network in space.
Very good. So who would be the type of person, team, company who would be an ideal first user of the SpaceAI network? Who are the people you want to work with first, or who are the types of project that would be most appealing to make use of SpaceAI, or who you want to work with to help expand the system?
Well, there we have very well identified the profiles of users that love our product, and from radio amateurs, that is a group of people that is like the early user of the internet. If we make a parallel, it's like, you remember the BBS? Well, the radio amateurs are the BBS users of space today. They have their ground stations, they are connecting to satellites, they are already operating to a space network, but like if we were in the BBS moment, where you have isolated machines that are not integrated into a network. So those users identify very fast the value proposition of a distributed ground station network with software-defined radio communications. Then makers, all the makers that are building different robots and also working with Internet of Things using like Raspberry Pis or Arduino. Well, we have a satellite for them to start playing right now and building solutions and robotics and infrastructure with less effort, because you already have in one machine the sensor, the computing, and the communications without any wires. And then, you have for all the AI community, but not at this moment, we don't see the user, the final user. We see the people who is working and they're researching and training and using different large language models, also as one of the users of this distributed computing infrastructure. And of course, the crypto community. All the crypto community, they love this. They already understand almost everything of what we are bringing to the table. And well, we have around 500 millions of users identified already as potential users today.
It's quite a broad audience, and I think I can probably relate, or maybe
we can summarize as all the geeks and nerds. That is the first community.
Exactly. Those early adopters, those people who are passionate about technology. But I think there are some fairly well-established industries in there. You talked about Internet of Things, right? And the fact that there are applications for NEO being used in monitoring pipelines today. Anywhere where you need a satellite-connected, wireless node network that can operate independently and securely, that's a potential use case or a potential operator for a NEO. That's not a guy with his CB radio sat in a shed somewhere.
Exactly.
That's multinational companies, their security teams, their operations and risk people. That's all of the above. The crypto community, of course, we get that part, right? So this is the creation of an IoT enabled ecosystem in space. So if you're building applications today for decentralized physical infrastructure networks or DePIN, if there are application builds for DePIN, they should be looking at SpaceAI saying, okay, well, how can I take my ground DePIN application, use it on SpaceAI and with SpaceAI tech to make it a space-ready application? Because there's 250 or 251, I can't remember the exact number, missions going out into space for the moon. Why wouldn't we be one of the SaaS or software as a service providers to somebody who's intending to go to the moon? Right? We may not have as many space privateers yet of individual eccentric billionaires who are going out and needing their social media networks to work with NEO just yet, but there are plenty of other applications you could imagine. So
yes, and the platform is designed, is open, is powered by Linux. There is no black box. It's very easy to interact with an open API, with an SDK. So it's ready to be integrated with pre-existing systems and to any language. So there is no limitations, and it's open source.
Very good. One final question that we did have in the chat here, which was specifically around the type or types of blockchains that are likely to be integrated with SpaceAI, because it's, as you said, you're looking at working with open standards. You're looking at making SpaceAI interoperable with multiple chains. Where are you on which blockchain or blockchains you're working with at this point in time?
Well, we use Hyperledger from Linux as the blockchain layer for the architecture. So it's crypto agnostic. There is no coin here. We are not selling any coin. We are just using that language to orchestrate resources, and so the Hyperledger Iroha, in this case, from Linux Foundation, is the answer. And
Got it.
that is
And from there, that protocol can then work or be integrated with Bitcoin, Ethereum, Cardano, Solana, Litecoin, Zcash, take your pick. That's a framework on which you can then build systems, decentralized exchanges, etc., that allow you to connect to the rest of the network of nodes.
Exactly. Imagine if you are in space, we have to be able to receive and to transact with any crypto asset, and that is what we have already deployed.
Maybe even Dogecoin.
Exactly, of course.
And remember,
Dogecoin.
when in space, no one can hear you meme. On that terrible joke, I'm going to leave it there. Diego, a final thought. How can guys find out more about SpaceAI? How can people follow you and what you're up to in the coming weeks and months?
Well, spaceai.com is the best place, and if you can register, and you can, it's free, so you can join the network and start building this distributed computer right now.
Amazing. Diego, thank you so much. I feel like I've learned an awful lot about the space economy, about the future of the integration of IoT, compute, edge devices, blockchain, the moon, and all of the above. Thank you for sharing that with the wider audience. Thank you for making it such an addressable and apparently normal topic. This is much bigger than most people realize, and I'm fascinated to see what happens next for you guys. So thanks very much for coming on the show, and stay safe out there.
Thank you very much, Tony. Have a nice day. Thank you, everyone, for the audience.
All right.